In this video, we're going to look at another example of calculating an iterated integral. So in this one, we're asked to calculate the integral from 0 to 1 and from 0 to 1 of xy root x squared plus y squared dy dx. So again, since the dy comes first, we're going to integrate the integrand with respect to y and then with respect to x. So when we integrate with respect to y, we treat x like it's a constant. If I can do this with a u substitution here, if I let u equal what's under the radical, then my du with respect to y is 2y dy. I have a y, so I need to adjust with a 1/2. So we have 1/2 x u to the 1/2 du. Antiderivative for that, well, the 1/2 x is just a constant. Antiderivative for u to the 1/2 is 2/3 u to the 3/2. Now remember that our limits of integration were in terms of y, so I need to substitute this I need to substitute x squared plus y squared back in for u, and then plug in 0 and 1 for y. So when we simplify what's in front there, we get 1/3. We have x squared plus y squared, the quantity raised to the 3/2 power. We're going to plug in 1 and 0 for y. In the first case, we get x squared plus 1. In the second case, we just get x squared. X squared to the 3/2 is x cubed, times another x gives us x to the 4th. So that's where that x to the 4th is coming from. Again, put 0 in for y. X squared to the 3/2 is x cubed, times x gives us x to the 4th. So the second term in the integrand is easy to integrate. We can use the power rule. The first term we'll need to use a u substitution again. I've got the u substitution, what you would use written on the other side, so you should check that this really is the antiderivative that we get in that case. And then again, we'll plug in 0 and 1 for x in this case. And when we do that and simplify, you should get 4 root 2 minus 2 all over 15.